Hi, so today we're going to work through an example of how to find code words using a generator matrix for a linear code. A generator matrix is used to define a linear code, and it's made up of linearly independent column vectors. So in our case, we have 5 columns, which means that we're going to have 5 linearly independent column vectors. These vectors form the basis for the code, and a key point is that for the code word to be valid, these vectors must be linearly independent because no vector can be written as a combination of the others. So once you have your generator matrix, you can encode a message by multiplying it with a message vector. So this message here will become the message vector u equals 1, 0, 0, 0, 0. That's a 0, by the way. And you just multiply these together to produce the code word. So this message vector will have the same length as the number of columns in the generator matrix, which in this case will be 5. And it's also given here in the question. And then the code word will be a vector of length n, or the number of rows in the matrix, which is also given here as 8. So here when I say that 8 is the code word, that's the length of the code word, and 5 is the length of the message. And so the generator matrix that we're working with has a very specific structure. So it includes the identity matrix as part of it. This is important because when we multiply it by the message vector, the result of multiplying the identity matrix by it will just be the message itself. And so the last part of the code word will just be the same as the original message. So this structure actually makes things a lot easier because instead of multiplying the entire matrix to find the code word, you only need to focus on the first few rows. This simplifies our calculation by quite a lot. But another thing to note is that when we're using our multiplication in GF2, it is basically the same as modular 2 arithmetic. You only have zeros and ones, and multiplying a 0 by anything is just going to give another 0, and the only way to obtain a 1 is to multiply 1 by 1. So if we line up our message with the first few rows of the generator matrix, we can just count the overlapping ones, and the number of overlaps in each row is equivalent to 1 digit of the code word. So if we do that now with part 1, we know that the message is always in the code word, and so our first message is 10000, and we just put that there in the code word because we know that anything multiplied by the identity is the exact same. And so we can do the same for the second as well. Now, as I said before, all we have to do is line up our message block with the first few rows of the generator matrix. And then all we have to do is count the overlapping ones. And in this case, our message only has one, so we only have to look at that one. We have 1 overlap in row 1, 1 in row 2, and none in row 3. So these will be our first 3 digits of our code word, and that will be our first code word. Now for our second code word, we do the exact same. And this actually isn't a very good example because it only has 1, so we only actually have to look at that column. And it just gives us straight away the digits. But if you had, for example, like 0, 1, 1, 0, 1, and in a row, maybe you had like 1, 1, 1, 0, 1, you would count these overlapping digits and go and notice that there are 3 overlaps. And because we're in GF2, it's the same as modular 2 arithmetic, and 3 mod 2 is equal to 1. And so that's how you would do those kinds of ones where you have more than 0 or 1 overlaps. Okay, and so for part 2, the key idea is that multiplying a message vector by the generator matrix will give us a linear combination of the columns in the generator matrix, which means that the resulting code word will always lie within the code's subspace, which ensures that it's valid. So when the question asks which of the following are also code words, it is asking which of these code words are valid, which of them are within the subspace. And so to find that, all we have to do is multiply the message from the code words by the generator matrix and identify what the correct digits should be. We know that the message is always included in the code word, and our messages are of length 5, so we just take the last 5 digits. And you'll notice that there are code words that have the same message, like for this one, but because we know that each message encodes a unique vector or code word, only one of these at most will be correct. So to work this question out, you just can use the exact same shortcut as before. So you take your message, line it up with the P rows of the generator matrix, and then just count the overlaps. And so we have 3, mod 2 is 1, 2, which is 0, and 3, which is 1, which means that our first 3 digits will be 1, 0, 1. which you can see is up here, this one, which means that this code word is valid and within the subspace, and the other code word that uses this message is not. And so we can do the exact same thing for the second message. And so we have 0, 1, and 1, which means that our correct code word will be this one, and the other one will be incorrect and invalid. So if we enter all of our answers into the numbers system now, we will notice that they are correct. This really isn't that difficult once you have these shortcuts, but make sure that you understand how this works and why these code words are valid and why these ones are not. But yeah, that's about it. Good luck with that. I hope this was helpful.